Rainwater harvesting is a system that captures, filters, stores, and reuses rainwater. Here's how it works and why it matters. Capture, filter, store, and reuse. The catchment is the roof. It sets both water volume and quality. Common materials include metal, tile or slate, and concrete, sure clay. Metal is smooth and inert, shedding water quickly with minimal contamination. Tile or slate works well but traps debris. Plan stronger pre-filtration. Concrete and clay tiles perform similarly to tile, with more texture-driven debris. Slope and area drive yield and maintenance frequency. Rule of thumb: 1 inch on 1,000 square feet yields about 623 gallons. Apply a runoff coefficient, about 95% for smooth metal, around 80% for rougher surfaces. Steeper roofs reduce exposure time and contaminants. Flat roofs can pond, increasing evaporation, algae, and maintenance. Before anything else, repair damage, remove overhanging branches, and address corrosion to improve water quality at the source. Treat the roof as precision collection equipment to reduce load on downstream components. Conveyance moves water from roof edge to pre-filtration. Gutters must handle peak rainfall without overflowing. Size gutters for maximum flow in local cloud bursts. Undersized gutters waste water at the worst time. Use screens or guards to stop leaves and debris entering pipes. Screens reduce maintenance but still require periodic cleaning. From gutters, water drops into downpipes without spillage. Prefer smooth-walled PVC or metal to prevent snagging. Avoid corrugated flecks. Ridges trap sediment and biofilm. Seal connections. Leaks lose water and admit insects. Many roofs have multiple downpipes. Consolidate flows. Use a sealed manifold into a larger graded wet pipe feeding central filtration and storage. Provide cleanouts and correct slope to avoid stagnation. The first runoff carries dust, pollen, droppings, and pollutants. If allowed into storage, it forms sludge and degrades water. A first flush diverter fills with the initial dirty flow in a vertical chamber. A float ball rises and seats, closing the diversion once the set volume is captured. After seating, cleaner rain proceeds to filtration and storage. A drip valve drains the chamber and resets the device automatically. Size the chamber at roughly 10 to 20 gallons per 1,000 square feet of roof. Mount at the downpipe before fine filtration. This single device prevents most roof-borne contamination from reaching your tank. First stage filtration is coarse. Mesh screens or basket filters stop leaves and insects. Keep this accessible for quick inspection and cleaning. Use a calming inlet to avoid disturbing settled sediment. For potable systems, add a 5-micron sediment filter to remove sand, silt, and rust. Follow with activated carbon to reduce organic chemicals, pesticides, and taste and odor compounds. Finish with disinfection. Ultraviolet light disables microbes without altering taste. Alternatively, chlorination provides a residual disinfectant throughout the plumbing. Non-potable uses may stop at coarse screening. Potable requires fine filtration and disinfection. Adhere to filter change and UV bulb intervals to maintain performance. Storage is the system's heart. Above-ground tanks or underground cisterns. Above-ground units are simpler and cheaper to install and service. Common materials include UV-stabilized polyethylene, fiberglass, and galvanized steel. Form factors range from slimline wall huggers to large cylindrical volumes. Underground cisterns save space and keep water cool, inhibiting algae. Installation involves excavation, a prepared base, careful placement, and backfilling. Expect access via a surface manhole. Inspection and cleaning are less convenient. Key fittings: a calming inlet, an outlet set above sediment, a screened overflow, and a bottom drain for flushing. Route overflow safely away from the building and prevent pest entry with fine mesh. Size storage by matching roof yield and seasonal rainfall to expected demand. Aim to bridge the longest dry spell without frequent shortages. Gravity can run soaker hoses or fill watering cans for simple, low-pressure tasks. Most household uses need higher, steadier pressure than gravity provides. Use a pressure-boosting pump paired with a pressure tank for whole house service. The pump fills a bladder tank, compressing air to store pressure. A pressure switch stops the pump at a set high point, for example 60 psi. As you draw water, pressure falls to the low set point, say 40 psi, and the pump restarts. This reduces rapid cycling and keeps flow consistent. Place disinfection after the pump for potable systems. Ultraviolet or chlorination per maintenance preference and code. Reduced water bills by substituting free rainwater for municipal supply. Lower demand on centralized treatment and distribution infrastructure. A practical sustainability upgrade with measurable resource savings. Emergency water availability during outages and droughts. Reduced stormwater runoff helps prevent local flooding and erosion. A rainwater harvesting system is simple, efficient, and sustainable. With proper design and filtration, it becomes a reliable water source for homes, buildings, and communities. Capture, filter, store, distribute. Engineered correctly, every link in the chain delivers dependable water on demand.